Alrighty, Unit 4 Simple Machines. The purpose of this video is to review the following concept. Levers! Levers! Law of the lever, first class lever, second class lever, and third class levers. Okay, there's a lot to it, so here we go. So the first thing we should go over is some vocabulary. The fulcrum. The fulcrum is located wherever the lever rotates. So here is the fulcrum right there. All right. The input force or the effort, it's like what you put into the simple machine, because this is a machine, right? And that is where you put force into the lever. So here, you push down, right? And when you push down, you have an input, and what happens is there is an output, and that's the output force, also known as the load. Okay, so it's just some vocabulary for you. So, the law of the lever. Here we go. It's kind of tricky, but here it is, and I'll show you some examples and everything. But pretty much you've got a lever here, you've got your fulcrum, your force input, and your force output, right? And what must be true is that the force input times the distance between the force input and the lever must be equal to the force output times the distance between the fulcrum and the force output. So you can imagine that with a lever, if you move the lever from here to here, it's going to make a difference, right? If you move the lever from here to here, it's going to make a difference with how much force there is. Okay, but this must be true. Here's an example. So how much is the force output? Right, you have a length A of 1 meter. Length B, 5 meters. Force input, so I'm pushing down with the force of 50 newtons, right? I push down with the force of 50 newtons right here, right? How much force do I get out of that? How much force do I get out of that, right? And let's do the math. Yeah, force input times 1 meter equals 50 newtons times 5 meters. All right, the force output you get, trust my math, is 250 newtons, right? So you're multiplying by 5 the amount of force that you are getting with this simple machine. Okay, so I put in 50 newtons of force and I get out 250 newtons of force. How can that be? How can that be? That doesn't seem like it makes any sense, right? Because, there's the conservation of energy, right? The law of the conservation of energy, right? So how can that be? Well, remember, hopefully from today, that work input must be equal to work output because work is energy. Force is not energy, work is energy. So the work input has to be equal to the work output. So think about this. The force input times the distance that you push down, so the distance that you move, so the force input times the distance that you move this down must be equal to the force output times the distance that you move this up. Okay, so how far you push this down with how much force, if you multiply that together, it has to be equal to the force output times how much you move that force output or that load. Okay, so let's do the problem. So let's say you push the lever down with your hand, with your force for 1 meter, right? So you push down for 50 newtons for 1 meter. You push down, all right. Um, so how far did you move the output for? So how far did you move the load? So if I push down here 1 meter with 50 newtons, I lift this with 250 newtons, but how far do I lift it? Well, if I do the math, I lift it zero point 0.2 meters, right, or 20 centimeters. So that's much less. So in the end, what's happening is that you're using a lot less force. You're using a lot less force to lift this load or to lift this force output, right? You're putting in a lot less force, and you're getting out a lot of force, but you're not moving that force as much. So the work still balances out. Okay. If you have a question about that, write that down now, and we can talk about it tomorrow in class because that's the trickiest idea, right? So as you increase the amount of force that you get out of a simple machine, you're decreasing the amount of distance that it travels because you need the work to be equal, the work input to be equal to the work output. Okay, I hope that makes sense. So what we've been looking at is a first-class lever. And in a first-class lever, the fulcrum is between the input and the output forces. So remember, an output force can also be called a load because usually you're lifting a load like an object with the lever. Okay, so here you push down with the force, the load goes up, right? And so it's useful for lifting heavy objects, blah, blah, blah. Here are some examples. This is an easy one, right? You're trying to lift a load and you're using a crowbar, right? Or you're trying to open a can of paint and you're lifting the load with like a, what do you call those? Screwdriver. This one's a little different, right? Here, your input force is when you squeeze, right? The fulcrum is the middle part, and the load is you cutting the paper, right? And so that's kind of a little bit tricky, but it is in fact a lever, right? Because here is the fulcrum, right? Here is the load. It's the same thing. Okay. Second class lever. In this case, you have the fulcrum on one end, and then the input force on the other end, and the load is in the middle. Okay, so you have, remember, effort is another way of saying input force. So here you have your effort, right? You're lifting something. The fulcrum is the wheel, so this is a wheelbarrow. The load is in the middle, right? And so that can be useful for carrying heavy things or creating, in this case, you're creating a lot of force here because you're moving this really far, right? And you're moving this part in the middle less far, and so that means that you're going to get a lot more force out of like this nutcracker. Okay. Now, third class lever, and this is the important one. And so this one, you have the fulcrum at one end, the effort is in the middle, and then the load or whatever you're moving is at the end, right? So fulcrum here, you're squeezing the tongs in the middle, the effort is at the end, right? Or here, fulcrum, effort, load with the fish, okay? So we're going to focus mostly on the third class lever because our mousetrap is a third class lever, and the point of this unit is to make a mousetrap car. Okay, so here we go. We have a mousetrap here, right? Here is the fulcrum. Here also is the input force, and then the output force is going to be the string. All right, the output force is going to be the string, which is tricky, but that's how it's going to be. So if you think about it, the longer you make the lever, the more distance this is going to move, but the less force it's going to have. The shorter you make the lever, right, the less distance that this moves, but the more force you have. And there's arguments to be made for having both styles. And yeah, we'll talk about that more in class. I'm gonna grade this, so make sure you do it. Also, please don't just send pictures of your finished graphic organizer to your friends because that's academic dishonesty. And remember, grades are not a reflection of your personal worth, but doing that kind of stuff is. All right. I hope you have a nice afternoon, and that is everything.